Welcome to today's paper reading. Today's paper is titled, Searching for Best Practices in Retrieval-Augmented Generation. This paper, authored by Xiaohua Wang and colleagues from Fudan University, explores optimal practices in retrieval-augmented generation techniques, which are currently under review. The abstract discusses the effectiveness of retrieval-augmented generation (RAG) techniques in integrating up-to-date information, mitigating hallucinations, and enhancing response quality, especially in specialized domains. However, it also highlights the challenges of complex implementation and prolonged response times associated with these techniques. The research aims to investigate existing RAG approaches and their potential combinations to identify optimal practices that balance performance and efficiency. Additionally, the study explores how multimodal retrieval techniques can significantly enhance question-answering capabilities about visual inputs and accelerate the generation of multimodal content using a retrieval as generation strategy. The introduction of this paper discusses the challenges associated with generative large language models, particularly their tendency to produce outdated information or fabricate facts. To address these issues, the paper introduces retrieval-augmented generation (RAG) techniques, which combine the strengths of pre-training and retrieval-based models. RAG provides a robust framework for enhancing model performance and enables rapid deployment of applications without necessitating updates to model parameters. The paper outlines a typical RAG workflow, which includes multiple processing steps such as query classification, retrieval, and re-ranking. It also highlights the complexity and variability in implementing each step, emphasizing the need for systematic experimentation to identify optimal RAG practices. The study aims to identify the best practices for RAG through extensive experimentation, comparing various methods and evaluating their impact on overall RAG performance. Figure 1 illustrates the comprehensive workflow of retrieval-augmented generation (RAG). The study thoroughly examines the role and impact of each component within the RAG process. By conducting extensive experimentation, the research identifies the most effective methods for each module, indicated in bold and underlined fonts. Additionally, the figure highlights the best-performing selections, denoted in blue, which have been empirically validated. This detailed analysis offers valuable insights into achieving optimal RAG practices, balancing performance and efficiency across various components. Ensuring accuracy in responses from large language models, LLMs, like ChatGPT and Llama is crucial. However, simply increasing model size does not resolve issues like hallucinations, especially in knowledge-intensive tasks and specialized domains. Retrieval-augmented generation (RAG) addresses these challenges by retrieving relevant documents from external knowledge bases. Previous works have optimized the RAG pipeline through query and retrieval transformations, enhancing retriever performance and fine-tuning both the retriever and generator. Effective retrieval requires accurate, clear, and detailed queries. Methods like query-to-doc and hide generate pseudo-documents from original queries to improve retrieval. Other studies focus on transforming retrieval source documents, such as LlamaIndex, which generates pseudo-queries for retrieval documents. Document chunking and embedding methods significantly impact retrieval performance. Common chunking strategies divide documents into chunks, but determining optimal chunk length can be challenging. Re-ranking is necessary to filter irrelevant documents, often employing deep language models like BERT or T5. Fine-tuning within the RAG framework is crucial for optimizing both retrievers and generators, ensuring faithful and robust generated content. Figure 2 illustrates the classification of retrieval requirements for various tasks. The tasks are differentiated into sufficient and insufficient categories based on the information provided. A total of 15 tasks are classified, with sufficient tasks not requiring retrieval and insufficient tasks potentially needing retrieval. A classifier is trained to automate the decision-making process regarding retrieval necessity. The RAG workflow begins with query classification to determine if retrieval is necessary. This involves categorizing 15 different tasks into sufficient and insufficient information groups, and training a classifier to automate this process. Next, document chunking is crucial for enhancing retrieval precision. This can be done at various levels such as token, sentence, or semantic, with advanced techniques like small to big and sliding window improving context retention. Finally, retrieval methods focus on selecting the top K relevant documents based on query similarity. Query transformation methods such as rewriting and decomposition are evaluated, with hybrid search combining sparse and dense retrieval proving effective. Table 1 presents the performance metrics of the query classifier. The BERT-based multilingual model achieved an accuracy of 0.95, precision of 0.96, recall of 0.94, and F1 score of 0.95. The table also lists the accuracy, precision, recall, and F1 scores for other models, providing a comprehensive view of the classifier's effectiveness. Table 2 presents the results of different embedding models on the namespace point/MSMARCO dataset. The LLM embedded model demonstrates performance comparable to BAI/BG large N, yet it is significantly smaller in size, making it a more efficient choice. The table includes metrics such as MRR at 1, MRR at 10, and MRR at 100, which are crucial for evaluating the effectiveness of these models in semantic matching tasks. Table 3 illustrates the impact of varying chunk sizes on retrieval performance metrics. The chunk sizes tested range from 2048 tokens down to 128 tokens. The average faithfulness metric shows a significant improvement from 80.37 to 97.59, indicating a reduction in hallucination errors. Similarly, the average relevancy metric increases from 91.11 to 97.78, demonstrating better alignment between retrieved texts and queries. These results highlight the trade-offs between context preservation and retrieval efficiency across different chunk sizes. Table 4 compares different chunking techniques in terms of average faithfulness and relevancy. The techniques evaluated include the original method, small to big, and sliding window. The average faithfulness scores are 95.74, 96.67, and 97.41 respectively, while the average relevancy scores are 95.37, 95.37, and 96.85. This comparison highlights the effectiveness of advanced chunking techniques in improving retrieval quality. Table 5 provides a detailed comparison of 5 open-source vector databases: Weaviate, Face, Chroma, Trant, and Milvus. The comparison is based on 4 key criteria: multiple index types, billion-scale vector support, hybrid search, and cloud-native capabilities. Weaviate supports cloud-native and hybrid search, while Face excels in multiple index types. Milvus stands out with billion-scale support, cloud-native capabilities, and hybrid search, making it the most comprehensive solution among the evaluated databases. Table 6 presents the performance of various retrieval methods on the TREC DL19/20 datasets. It highlights that supervised methods, particularly LLM embedded combined with HYDE and hybrid search, achieve the highest scores. Unsupervised methods like BM25 and Contriever serve as baselines but are outperformed. Notably, query rewriting and decomposition do not significantly enhance retrieval performance. The table underscores the effectiveness of hybrid search with HYDE, balancing performance and latency, making it a recommended default retrieval method. Table 7 examines the effects of various concatenation strategies for hypothetical documents and queries using the HYDE method. The table highlights that combining multiple pseudo-documents with the original query can notably enhance retrieval performance. This approach is crucial for optimizing the retrieval process, especially in scenarios where original queries lack sufficient semantic information. Table 8 illustrates the results of hybrid search across various alpha values, which control the balance between sparse and dense retrieval components. The study evaluates alpha values ranging from 0.1 to 0.9, revealing that an alpha value of 0.3 provides the optimal performance. This finding suggests that fine-tuning the alpha parameter can significantly enhance retrieval effectiveness. However, it also highlights a trade-off between retrieval performance and increased latency, indicating that while higher alpha values can improve effectiveness, they also lead to slower retrieval times. Table 9 presents the results of different re-ranking methods applied to the development set of the MS Marco passage ranking dataset. Each query's top 1,000 candidate passages, initially retrieved by BM25, are subjected to re-ranking. The latency for each re-ranking method is quantified in seconds per query. This table serves to compare the effectiveness and efficiency of various re-ranking techniques in enhancing the relevance of retrieved documents. Table 10 compares various summarization methods across three benchmark datasets, NQ, Trivia QA, and Hotpot QA. The results indicate that Recomp achieves the best performance, highlighting its effectiveness in summarization tasks. Lingua, despite not performing as well, demonstrates superior generalization capabilities, suggesting it could be a viable alternative. Selective Context, which employs a non-query-based approach, provides a contrast to the query-based methods evaluated, offering insights into different strategies for summarization. Figure 3 presents the results of generator fine-tuning. Models trained with a mix of relevant and random documents, Manager, perform best when provided with either gold or mixed contexts. This suggests that mixing relevant and random contexts during training can enhance the generator's robustness to irrelevant information while ensuring effective utilization of relevant contexts. Therefore, the practice of augmenting with a few relevant and randomly selected documents during training is identified as the best approach. The study identifies several key practices for optimizing RAG implementation. Firstly, the query classification module significantly improves both the effectiveness and efficiency of the system, leading to an average score improvement from 0.428 to 0.443 and a reduction in latency from 16.41 to 11.58 seconds per query. Secondly, the retrieval module, particularly the hybrid with hide method, achieves the highest RAG score of 0.58 but at a high computational cost. Therefore, the hybrid or original methods are recommended for lower latency without significant performance loss. Lastly, the re-ranking module is crucial for system performance. The absence of this module results in a performance drop. Mono 5 re-ranking achieves the highest average score, emphasizing the importance of re-ranking in enhancing the relevance of retrieved documents. Table 11 presents the results of the search for optimal retrieval-augmented generation (RAG) practices. The table highlights the performance of various modules under investigation, with the underlined method indicating the selected implementation. The average score is calculated based on ACC, EM, and RAG scores across all tasks, and latency is measured in seconds per query. Key findings include the significant improvement in overall score and reduction in latency time due to the query classification module, the highest RAG score achieved by the hybrid with hide method, and the efficacy of the Mono 5 re-ranking module in enhancing document relevance. In this discussion, we explore two best practices for implementing RAG systems. The first practice focuses on achieving the highest performance by using a combination of query classification, hybrid with hide retrieval, Mono 5 re-ranking, reverse repacking, and recomp summarization. This configuration achieved an average score of 0.483, but it is computationally intensive. The second practice aims for a balance between performance and efficiency by using the hybrid retrieval method, TILDF2 for re-ranking, and maintaining the same repacking and summarization methods. This approach reduces latency while preserving performance. Additionally, we have extended RAG to multimodal applications, incorporating text-to-image and image-to-text retrieval capabilities. This extension offers advantages such as groundedness, efficiency, and maintainability. The workflow involves using text queries to find similar images and matching user-provided images to find similar ones, with generation models employed if no matches are found. Future plans include expanding this strategy to other modalities like video and speech. Figure 4 depicts the workflow of multimodal retrieval, focusing on two main processes, text-to-image and image-to-text retrieval. In the text-to-image retrieval process, a text query is used to search for images with high similarity in the database. If a match is found, the image is returned directly. Otherwise, an image generation model creates a suitable image. The image-to-text retrieval process involves matching a user-provided image with images in the database. If a high similarity is detected, the corresponding caption is returned. If not, an image captioning model generates a new caption. This workflow highlights the dual capabilities of retrieval and generation in handling multimodal queries. In this study, the authors aim to identify optimal practices for implementing Retrieval-Augmented Generation, RAG, to improve the quality and reliability of content produced by large language models. They systematically assessed various solutions for each module within the RAG framework and recommended the most effective approach for each. Additionally, they introduced a comprehensive evaluation benchmark for RAG systems and conducted extensive experiments to determine the best practices among various alternatives. Their findings contribute to a deeper understanding of RAG systems and establish a foundation for future research. However, the study has limitations, such as the evaluation being limited to representative chunking techniques due to costs. Future work could explore joint retriever-generator training, investigate different chunking techniques, and expand the research to other modalities like speech and video. Thank you for watching.